Now that we introduced ourselves on the longitudinal waves, let's see if we can derive the equation for the amplitude pressure. So, suppose here we have a cylinder here of the fluid that we're talking about. Here is the point x, here is the point x plus delta x, so all this is delta x. The cross-sectional area is A, so the volume is A times delta x. If we now produce, let's say here we are on a piston, or on a tube, this is my piston, and I'm talking about this volume. If I compress here, I will move. I can either move this, if I return this, it will move to this, but for now let's suppose that the function y of xt represents the displacement of this particle, or the particles that are here. So for example, if this is now here, for example, and I have g of x plus delta x t, now represents the movement of these particles, this on the x direction. So now I have the, remember that the bulk modulus is equal to the negative of force divided by area, all of this divided by the change in volume divided by the volume. So this is the negative of the pressure, or you can say it as change in pressure divided by the V on the volume. So if I want the pressure, I have first V, the volume is equal to the negative of the pressure, and then I switch signs, and I have, this is the equation to which I'm going to work with. So I have that the dx is this distance. If I want the volume of this, I have the volume is 8 times delta x. The change is, I have y of x plus delta x t minus y of x t. This would be my change in volume. All of this, if I divide this by the delta b, by the x, I would have that this is the y on the x. So this is the derivative of the y. Remember that y represents the displacement. So this is the first derivative of the displacement. So this is velocity, and what is the equation of y of xt, or y of x plus delta xt, is y, let me put it here. I have y is equal to a cosine of kx minus omega t. So I have that the partial y on dx is here will be minus k a sine of kx minus omega t. This is the y on dx. Alright, so I have certainly taking here the limit as delta x approaches to 0, and so I have that this is the change in volume divided by v. So I have that minus v times dy dx by dx is equal to the change in pressure, or I have that the change in pressure is equal to the bulk movement times k times a times the sine of kx minus omega t. This is the equation of the pressure. This is called the pressure amplitude, and this a is the or actually, if you want better, I can call this S or something like for displacement or something, because I don't want to confuse this A with this A, that is the cross-sectional area. So let me put it as S or S maximum. This means the maximum amplitude. This is called the displacement amplitude or maximum amplitude, and this is the amplitude pressure. So the amplitude pressure is proportional to the maximum amplitude, and the maximum amplitude pressure submax is equal to what's the maximum value of sine of this? The maximum value is 1. So this would be just the bulk movement times k times the maximum amplitude or the displacement amplitude. So we can substitute this here, and we have that the amplitude pressure is equal to the maximum change of the pressure times the sine of k of x minus omega t. This is the equation of the change in pressure, and we use this formula of bulk movement equals the negative change on pressure divided by the volume on volume. But if you remember, also we have that the bulk movement is equal to rho, that's the density, times the velocity squared. So on this formula we can also put it as the change in pressure is equal to the density times the square of the velocity times k s maximum sine of k x minus omega t. Now remember that k is the linear wave number, so k is equal, yes, to 2 pi over lambda, 2 pi over lambda, but also we have that velocity. Let me recall, velocity is equal to the angular frequency omega divided by k. So I have k is equal to omega divided by velocity, and so here I have that the change in pressure is equal to density times square velocity times omega divided by velocity times the maximum amplitude times sine of kx minus omega t. So the change in pressure, the change in pressure is equal to the density times velocity times omega times the maximum amplitude times the sine of kx minus omega t. This is the maximum pressure. In future video we will talk about more about pressure, the relationship, and from this we will continue on to the intensity of the longitudinal waves or sound waves. So for now, this is the pressure.